Okay, we're back in RStudio and we're going to create a scatterplot using matrices. And why would we want to do that? Is because we want to review many quant variables and not just two. Prior video we did two, now we're going to look at a number of them because it could get unwieldy and we're trying to put things on a single screen to sort of make our job easier. So let's load or get the Google correlation file. Recall that that was the file, publicly available file that looks at the standard deviation statistics state by state as compared to the national averages on a couple different variables. Let's look at that, and you can see down here variables would be state, state code, whether you search for data visualization, Facebook MBA, whether you have an MBA team in your state, whether you have a degree, and whether you have a formidable statistics program in your K through 12 educational system in your state, and what region that state was located in. So let's look at how to do a basic scatter plot. Create the matrix, and we use the pairs function, and this will place these quantitative variables into the scatterplot matrix. And we've selected that the primary, the first value we're going to load in is the data viz, and then we're going to look at the degree and the Facebook and MBA, and we're going to load that data from the Google data frame that we've created earlier. So let's run that. And there we have it. So you can see it's a little bit unwieldy in that the quant variables are going down here on the diagonal. So we have data viz and the degree and what that correlation looks like, the scatter plot looks like, and then equivalently we have similar plots going down here relative to the variables on the diagonal. Up on the top we have the correlation coefficients, but it doesn't really sort of, I'm going to give you a basic review of what it looks like. It doesn't tell us any numbers or anything like that, but it gives you a really high level view. So let's sort of clean this up a little bit by using a function in our classic psych package called pairs.panels. And so let's install that psych package. Okay, the psych package is loaded, and let's drop it into the library, and let's run this function called pairs panel. You can see that it's a concatenation, and that numbers 3, 7, 4, and 5 are relative to the data set. In other words, the position 3 in the data set is the data visualization variable. Position 7 is the degree. Facebook was the 4th position in the data file, and then the 5th position is the MBA. And notice that I have here a gap equals 0, because you can look at the bottom scatter plot here. You can see that there's spaces in between each one of these boxes. We're going to try to get rid of that. So we're going to say the gap in between each one of these values in the matrix, we're going to bring it down to 0 to make it sort of more condensed. So let's run that guy. So there we have it. Let's zoom in on this guy and let's look at it a little bit further. You can see we have, it's the same information but visually sort of more a better understanding. And we can see that the variables are heading down again in the diagonal. And now we have histograms in each one of these. And we also have a line, and that line is a kernel density estimator, the overlay. The overlay on that histogram is a kernel density estimator. And for those who have Linux or Unix background, you know what a kernel is. But the kernel density estimation is really a mathematical tool. It sort of estimates the probabilities of the density function of a random variable. Back when I first got out of college, I got out of college as a systems engineer, and I worked on signal processing on probably a year into my job. I was working on satellites, and on signal processing we had to do a lot of these estimations using PDFs, probability density functions. Really cool stuff. So anyway, it didn't go away, it's still here. So we got histograms, and we have this kernel density estimator to sort of give you a feel. You can see where, it's based on the word density is actually related to volume. So you can see down here, you can't really see these, and I can't see them either, even if we zoom in. I think these are sort of where the values are, and you can see that they're all here centered around here. I mean, this could almost look like a normal curve, but it's not. And you can see how the data sort of squeezes in the middle here, and that's why you have this peak. And each one of these are spread out, and you can look at all the different curves and sort of make your own projections or do some analysis, but I probably don't want to do that. And so let's look at some other things here. Let's look at this. Let's just pick on this one, for instance. The red circle in the middle, the red dot, I should say, the red dot in each one of these is the mean value between, in this particular one, is the mean value between the relationship between the data visualization and whether one has a degree. That's the mean value. And from prior video, this red line is the lowest smoothing line, the LOWESS smoothing line. And then the oval, or the circle in some cases, the sort of round object or ellipse object, is the confidence interval for the correlation coefficients. And we can look at this one down here, which is the relationship between a degree and an MBA team. You can see that it's more round, so it has really less association. Whether one has a degree in an MBA program, there's very little sort of relationship there. So the rounder circles indicate that there's less association, as opposed to this one up here, where someone who has a degree excuse me, someone who has a degree versus whether they searched for data visualization, there's a stronger association. So the ellipse would mean that there's a stronger association because it's following this trend line. So that's where that's coming from. And on the top, these are the actual correlation coefficients numerics, as opposed to the plots that we saw earlier. Let's see. Let's pick on this one right here. The correlation coefficient between data visualization and a degree is 0.75. It's pretty strong. And you'll recall from statistics that the correlation coefficients go from 0 to 1, just like probability, and that 1 is a perfect sort of relationship, and if the number is 0, it has no linear relationship. And you can see also that this 0.75, you can look at the trend up here, so you can see that it's a positive correlation coefficient. Now we look down here, negative 3.7 and negative 0.64 in the aggregate is pretty strong. It tells you a little bit about it. Okay, so that's about it. We've sort of shown two different ways of how to look at scatter plots and matrices. The first one is a real quick and dirty basic one, and the second one, after installing the psych package, tells us a little bit more on the relationships and the association between how these variables interact.